In this video, we'll be discussing the second part of the computer overview. We'll be discussing few topics that we left out on the first part. So let's start with the first topic, which is the primary memory. In primary memory, we have discussed about RAM and we have discussed about ROM. Now, what is RAM? RAM is a random access memory, which is smaller than the size of a ROM, which is a read-only memory. RAM is a primary memory, is faster. Okay, so if you don't have a RAM in your computer system, our computer system won't be booting up. Okay, now there are different types of RAMs. They are categorized especially under dynamic RAM and static RAM. Now, a dynamic RAM, these are made of transistors and capacitors. Okay, so they have they are used widely in all the computer systems that we have in our households. Okay, they are a bit slower when it comes to the working capacity regarding to the static RAM. Okay, on the other hand, static RAMs are made up of flip-flops, so they are used in a commercially viable computer system, which are used to make a lot of works. Okay, a lot of scientific research and works. So they are a bit faster while coming down to their working capacity than the dynamic RAM. Now, let's come to the ROM. We'll be discussing the RAM part later in other chapters. Let's discuss about the ROM. A ROM is a read-only memory. So this is the memory where basically the manufacturers put their information or pre-programmed codes regarding a particular computer system. Okay, now let us look into the elaboration of the ROM section that we are discussing. So as I said, we have PROM, which is a programmable ROM. We have EPROM, which is erasable programmable ROM. So now when it's come to programmable ROM, the ROM can be programmed for once. When it comes to erasable programmable ROM, the ROM can be programmed many times. When it comes to electrically erasable programmable ROM and flash electrically erasable programmable ROM, these are a bit upgraded version of EPROM, which are faster. For example, EEPROM is faster than EPROM, and flash EEPROM is again faster than the EEPROM. Now, then we come to a mask ROM. A mask ROM is basically used where a program is integrated into an integrated circuit by the manufacturer. So this is the entire hierarchy of a read-only memory. The first part of the video, we have discussed about various categories of software, and in various categories of software we have one category which is called as a language processor, and which is very important in itself. Now, what does a language processor do? As I've discussed in the previous video, a language processor basically translates a human understandable language to a machine level language. As we know that computer only understands 0 and 1. So we have three categories of language processor which evolved with the different generations of computer systems and computer programming. So the very first category are called the assemblers. Now, what did assembler do? The assembler basically converted the assembly level language, which was basically a first generation of computer programming languages. Okay, it had small English terminology related codes. For example, add. So this kind of codes, which basically translated into a machine level language, which is 0 and 1. Now, let's come to the compiler. A compiler then got upgraded from the assembler and was used in second and third generation of programming language as the programming language concept evolved. A compiler basically compiles the entire program at a go. Okay, creates a different memory of it, and then finds the error and notifies it to the user. Once the error is rectified, the compiler again compiles the file. Then it changes the source code to an object code, and that is how the object code is further translated into machine level language, and this process continues vice versa. Okay, the interpreter on the other hand is very similar to a compiler, but the basic difference between a compiler and an interpreter interprets a code or a page of code line wise, and if it finds or if it come across an error, it stops, it asks the user to rectify the error, and then it continues to the next line. Okay, so in a way, if we need to compare between a compiler and an interpreter, compiler works much more faster then the interpreter. Okay, so the programming languages basically that are used for compiler, that are used by the compiler are C programming languages, the C++ programming languages. When it comes to interpreter, there are various second generation and third generation and also fourth generation languages which basically use the interpreter. Java as a programming language uses both compiler and an interpreter to change its source code to an object code. So in this topic, we'll be discussing about the mobile system organization. Basically, we'll be discussing about how the smartphone devices in today's world does work. So as you know, smartphones are a very good example of convergence of technologies. We can do a lot of things with the help of our smartphones. That is the reason they are named as smart. We can simultaneously do multiple tasks. Like we can listen to music, we can edit a file, we can watch a video, we can browse the internet, we can do a call. Okay, so it's not only about communicating. It has opened a door for a lot of things put together. So it's very important to know how a mobile devices in today's era does work, because it's such a small device that comes under the palm of our hand, and we have the entire world in the palm of our hand. So it's very important to understand the working of our mobile system. As you can see in the diagram in your screen, that a mobile system organization are basically made up of different small modules which are combined and amalgamated and then give you a particular structure of a device that works for a lot of things. Now, the very important things that we have in our mobile system organization is the CPU. You can see in the middle of the diagram, the CPU consists of communication processor, okay, which is a digital signal processor. Okay, now when it comes to a communication processor or a communication processing unit, this is a subsystem that is responsible for making and receiving phone calls on a mobile handset. So it has a digital signal processor that helps to work with the radio frequency transceiver and the audio subsystem. Okay, and then we have the other two components of the CPU, which are called as the application processing unit or APU, or the graphical processing unit or GPU. Okay, now these things are then this is the important part, which is the CPU, the central processing unit. With this, we are then connected with the display subsystem. So as you know, all the smartphones these days are touch sensitive. So it has got a touch sensitive interface that basically works as a keyboard and also a display screen. Then we have a storage area, which is basically we have two types of storage. We have a primary storage, we have a secondary storage. The storage area is meant for the external storage. Okay, and then we have read-only memory and random access memory, which basically makes the memory module of the mobile system organization. And then we have codec. Now, what is a codec? A codec is basically something which does for coding and decoding of our signals. So we have audio decoders and we have subsystem of speaker decoders. So that means we have ADC and we have DAC. Okay, so as you can see in your picture, we have ADC and we basically have DAC. Okay, so they are basically used for the coding and decoding of particular signals. And then we have the power management. A mobile device requires a powerful power management. We have the battery pack, we have the charger, we have fast chargers, for example, we have battery management. Okay, and then we have the radio frequency transceivers, we have the SIM that basically is required to activate a mobile device, and then we have a camera unit inbuilt. So it's not only about how we communicate, it's not only about how we listen to music, it's not only about how we watch videos or play games, but it's also about the camera. So mobile devices these days are basically used
for clicking wonderful pictures which are rather compared with the modern days DSLRs. So this is the entire graph or image of how a mobile system organization does look and what goes on inside a mobile device, which is beautifully bundled and which looks attractive and then is given as one unit to the users. Thank you for watching the video.